I am hoping that this video will help you in doing formula of a hydrate calculations. So I decided to go right to the practice problem, and it's pretty good, except it has a few terms that might throw you, so that's why I'm doing the video. So turn to page 340 and let's get started. The substance, first of all, that they're talking about is a hydrate called copper sulfate. And it's not copper sulfate all by itself, it's copper sulfate as a hydrate. When we heat copper sulfate, we are going to get this stuff over here, which is copper sulfate without water. So this is the hydrated copper sulfate, and this is the copper sulfate. The difference between them is just heating. And this will turn blue again if it sits long enough and become to look like this, because that's what salts do. They absorb water from the air. So what we're doing now is taking an example of 2.5 grams of blue hydrated copper sulfate, and there's a name for that, and we'll get to that at the end of the example. After the heating, you see the heating is the event. That's what takes us from this to this. And so the white anhydrous copper sulfate remains. And you're supposed to find the formula for the hydrate. And then we're supposed to name it. And that's what you're going to do in your lab tomorrow. So the hydrate's here, and the hydrate after the water is lost, which is just the salt itself, is sitting here. Sometimes a picture really helps to get this well in mind. So let's start with the given. That's what they call the known in this example. And you're given the mass of the compound with the water. Okay, so that's the hydrate. And then you get the mass of the anhydrous compound, which is what happens when we heat this and it becomes this. So next thing off is to get the molar mass of this guy. And the molar mass, which is water, that's what we're driving off with the heat, and then the molar mass of the copper sulfate. And so once we have those two things, we can start doing the calculations needed to get the formula of the hydrate itself, and then finally name it. So the first step that we do is on the next page, and here we're going to take and we're going to, oops, I didn't want to bring both those arrows. We're going to take this arrow and bring it on over here, and you can see the mass of the hydrate is going to be the copper sulfate with the water. So this is the salt as the hydrate. Next, we're going to look at this guy. What do we have here? That's the salt without the water. And they're calling it in this thing here the anhydrous, or without water salt. And this is the hydrated copper sulfate that has water with it. All right, next thing that we're after is to go down here and look at our molar mass, and hold on just a moment. Now, when we get to this next section, which is right in here, what we're doing is we're going to calculate here the, oops, missed, here we go. Yeah, the molar mass of copper sulfate, we've got to have that, and the molar mass of copper sulfate is given right here. Oops, let's get this back. Okay, is given right here, bingo. And that's what 1 mole of copper sulfate weighs. So we take our 159 grams of the anhydrous copper sulfate to get the moles of copper sulfate. And that molar mass right down there is what makes that all happen. Now, this is the moles of copper sulfate that we actually have in the experiment. Now when we go down here, we wind up with 91 grams of water, and we want to change that into moles. So we do that with the molar mass of water. And that's what the 18.02 is. and that gives us the 0.50 moles of water. Now, the next step after doing this, we want to get the ratio of the moles of water to the moles of copper sulfate. And to get that ratio, we simply take these two numbers and put them into this fraction. And you can see here's our moles of water. And here we go. Our moles of water were calculated here. There we go. And the moles of H2O and the moles of copper sulfate as a ratio is what they're calling X. And these two together, moles of the salt will always be on the bottom because it will be the smallest number of moles. And essentially what we're doing is we're saying for every copper sulfate, how many moles of water do we have? For every mole of copper sulfate, how many moles of water do we have? And that's what that's all about. So when we take our 0.5 from up here, 0.05 of the water, and we put on the bottom the 0.00996 moles of copper sulfate down there, then we can go ahead and get a proper mole ratio of the water to the copper sulfate, because we're going to divide the top and bottom by the same number, which is this guy. Okay, because he's the smallest number, that's what we're going to divide both the top and the bottom with, exactly like we did in our empirical formula calculations for the homework that we did a couple nights ago. So here we go. We've got a ratio of 5 waters to every copper 2 sulfate pentahydrate. And the name that we're getting is copper 2 sulfate because copper has a 2+ charge, told to us by this, and it's with sulfate that is one of our memorized ions guys, and he is a 2- always, and the penta comes from the 5, and hydrate because this is a hydrate. And we always designate hydrates with this dot between the compound and the water. The compound is almost always a salt, and then we have some number of molecules of water hooked up to it. That's it. I hope this makes calculation of tonight's homework a lot easier for you. Thank you for watching.